Welcome to the third video in building your own AI. In this video we're going to start on our AI logic with a focus on getting communication going between our client devices and the brain. In the last video we saw two Python scripts used to test our message queue, one to listen for messages and one to send messages. We'll take a similar approach in starting our AI logic with the brain listening for messages and a client script to run a motion sensor and send messages. The two scripts could be run together on the same device in different terminal windows, or they could run on separate devices. Eventually, however, I'll have multiple devices running the client script, but there should only ever be one brain script running. And of course they'll communicate back and forth via the message queue. The scenario we're going to be testing is to have a Python script, our client Python script, running on a Raspberry Pi. That's going to be controlling the camera and using the camera to detect motion. When motion is detected, it will take a photo. That photo will then be sent through the message queue to the script running on the brain side of things, and there the photo will be analyzed to determine what objects are detected using machine learning algorithms, and any objects will be then stored in a list in a JSON document. That JSON document will be inserted into a channel in the message queue that is specific to the device, the client, that actually sent the photo. Then our client script will be able to pick up that JSON document from that channel on the message queue and see what objects were detected. So the link that I'll have in the comments will lead you to GitHub here, where I'm storing all of the code, and you can see here that I have the brain scripts and the client script that we'll be working with in this video. Let's take a look at the brain script. You can see at the top here that I'm just importing those Python libraries that we discussed earlier. And here we're setting up some variables. Note the use of this variable here, client name. This is where we store the name of the channel that each component is going to be listening to. So the brain is going to be listening to the message queue on a channel called central. We then set up a couple of functions. One, it's not so important right now, but I've left it in to test the internet. Later on we'll be using the internet to do some calls out to APIs, but it's not actually used at the moment. And then here's our callback function, which is actually the one that's triggered whenever a message hits that central queue or the central channel. We'll come back to that in a moment. Down here is where we kick off our code. We start doing some debugging, which is very important at the moment while we're developing our code. You can see here I'm setting up a variable to, or rather a dictionary, to hold all of my environment variables. This is essentially going to be that context element that we discussed when I was going through the architecture. And then down here you can see, very similar to our test script we use when connecting to the message queue, that we set up our connection and then open our channel listening on client name. So as soon as a message comes through on that particular channel, what it's going to do is trigger our callback function here, which is going to receive a couple of inputs, and this is the standard way that the message queue or the Pika message queue library works. It sends through the particular method, some properties, and the body information. Now the body is going to be our image that comes through for our motion detection, and we're sending through a number of properties here which enable us to firstly identify which particular app has sent this, and in our case it's going to be the motion sensor app on our client, what type of content it is. Now again, in our case it's going to be an image, but remember this particular function here is going to be used for every sort of message that is sent through our message queue. So these help us identify what we need to do with that data once it's received. We also then pick up the reply to. This will be the name of the channel we need to reply back to, so the channel that our client is listening on. And then we're going to set up callouts to particular chunks of code depending on what was the type of sensor that sent the information through. So we're starting with our motion sensor. Whenever that's detected, we're going to load up our logic in a file called brain_motion, and we'll take a look at that later. And we're going to call a function in there to basically analyze the image for content, and we're passing in all of these parameters so that we can leverage them in there as well. So let's now take a look at the client code. So here's our client code, and it starts out very similar to what's happening on the brain. We load up our Python libraries. We define our connectivity details. Remember, this is the particular channel we're going to be listening on, so I've just got one client at the moment, and I've used a default name of client default. We again have the similar functions here to test the internet and our callback function. Note that I'm not actually doing anything with the JSON yet that's going to be sent back. I'm just going to print it to the screen to make sure we do receive it. And then our code kicks off. So I'm storing a lot more here in the environment variable here, including the connectivity, because we're actually going to need to run multiple threads, multiple processes on our client for the scenario of 1, being able to constantly listen to our message queue, and 2, to then be able to run multiple sensors doing multiple things. So note when we come down here, we test for the internet again, we try and connect to our message queue. We then start to kick off those multiple sensors. So what I'm actually doing here, it's looking at a variable to say, should we be using the motion sensor? If so, then kick it off in another process. And that means I'm then able to come down here and kick off my constantly running process monitoring the message queue for data that comes back. Now when I kick off my sensor, I pass in the environment variable, and that means within the sensor I have all of that information, such as connectivity to the queue, that I can use if I need it. So let's actually take a look at the logic of the sensor itself. So the code that's leveraged by our brain and client scripts is kept in a subfolder. So here's the motion sensor script used by our client script, so let's take a look at that one. And it's basically a class of functions here, which once we kick those off down the bottom here, it's calling a function called run loop, and that's just going to basically sit there waiting and checking one of those parameters there to say, should we be testing for motion? Once the environment variable changes and says yes, we should be testing for motion, it then kicks off a process of detecting motion with the camera. And what it's doing here is just taking a series of frames with the video camera and then comparing them to each other to determine, has this second frame here changed substantially compared to the first frame? If so, then something must have moved. When it does detect movement, it's going to call another function, which is to trigger a detection event. So when a detection event occurs, it then comes down here and again checks some parameters here to say, are we in, say, secure mode and we need to do something about this, or do we want to identify the person? We convert it into a string using base64 encoding that's easy to, or rather to send over to the message queue. We then set up our properties where, these are the things that are telling our brain at the other end that it's an image that's coming through. Here's our client name that we're passing through. It's the motion app that is sending the data. And then we go ahead and we send that through on the message queue. So that's how the sensor works. And then let's now take a look at the brain logic that is going to be handled once our brain picks up that message and then passes it off to be processed here. So in our brain logic, again, we're importing the necessary client libraries, including the computer vision library, which is used by both the motion sensor and the motion logic here. Again, there's a class of functions here that are used. And what's happening here is, here we go, so it's detecting if the content that was sent through is an image, it's going to decode that content that came through in the body to get us back to essentially a frame that can be used to be analyzed with the computer vision library. And we're then going to pass that off to our detector API to detect whether people are detected in there. And it's using a couple of machine learning models that have been saved here to try and detect a person. So let's take a look at how all this works in practice. Okay, so here you're looking at the Raspberry Pi, and I'm just showing the code inside the motion detector here, where we're actually using the logger to show the time before and then after we've sent the data to the message queue, so we find out how long it takes for that round trip. So let's kick this off. I have the message queue and the server component running on my laptop. It's now connected to the message queue, as you can see there, and in a moment we should see something picked up. It takes 10 seconds or so each time, and there we go. So as you can see there, we have our JSON that's been returned showing that one person was detected. Let me just get out of shot and give that a test without myself in there. Well, that's interesting. So it's detected the sofa in the background, which is behind me, and as I move back in, there we go, we have a person detected. So you can see here it's taking less than a second actually in most cases as a round trip. So that's pretty impressive and a very successful test. And remember, please subscribe if you want to be notified when the next video comes out. Thank you for watching.